Okay, Lancers, here we are, section 12.3 of two parts, one of two parts. So this one's called Inscribed Angles, and just as a reminder from the last two sections, we've talked about tangents, where the tangent line just goes right on the outside, and then the next section was chords, where now the chords just go from one end to another. I talked about a bunch of rules. And so now what are inscribed angles? Inscribed angles are simply angles that are created by two chords. Okay? So if we look at the definition here, an angle whose vertex is on the circle and sides are chords of the circle is an inscribed angle. So let's get into some terminology. Like I said, we just talked about two chords. So here's chord number 1 and chord number 2, and so notice they create an angle right there. So that's called an inscribed angle. Yes, that point has to be touching the outside. Also, there is the intercepted arc, just as we spoke of before, and so that's that intercepted arc right there is created by the two chords. Okie doke. So here's your first rule. Super important to understand this rule, and it's not so bad. Basically says we have the measure of an inscribed angle is half the measure of its intercepted arc. So if this is 30 degrees, then the measure of its intercepted arc, measure of arc AC, is going to be 60 degrees. All right, so that is that, and vice versa. So if this was 60, then this guy is going to be 30. So hopefully that makes sense, and hopefully it's not too complicated. Let's get into a few more ideas behind intercepted arcs. There are a couple cases to consider. I'm just going to go over these briefly, then we'll do a quick example problem. So 3 cases, right? And they just have to do with where they are, basically. So you have case number 1, the center is on the side of an angle. All right, so there's our center. And notice in this case, the center is inside, and in this case, the center is on the outside. Now, does that mean anything according to, or does that change the theorem up above? Actually, it does not. Do we want to do this proof right here? No, we do not. All right, so skipping proofs. Okay, so let's get into our first example. Example says, what are the values of A and B? All right, so let's take a look. All right, as I zoom in, and hopefully I don't make the screen go dark there. So we want to see what the values of A and B are. So when we look at A, here's A, and let's just trace that out. A is going to be from here all the way to there. So that's A, okay? So that is A, angle of A, is actually the same thing as the measure of the arc PT. And so let's take a look at what PT is made up of. When I say that, I mean the two chords. So here's chord number 1, here's chord number 2, and so notice 60 degrees is a measure of that angle. So in fact, let's do this. Let me take this guy here, throw it over here. And so I'm going to say the measure of the angle of, I'll just call that Q, hopefully you guys are okay with that, is 60. And so remember, that intercepted arc is twice the angle, so 60 times 2. So the answer is 120 for the measure of arc A. All right. Okay, so moving on, let's go to the next one. How about B? And so if you notice what B is actually this angle here. And B is made up of these two chords, so chord RS and chord RP. And if we look, yep, see that giant arc right there. So I could say the measure of the arc PTS, or I can even say PS, but we'll just go in that. We'll list all 3 of those, is equal to 120, right, from this guy. Okay, and then we're going to add in 30. So that measure, PTS, is equal to 150. And again, right, so now that we have the measure of the arc, we're going to go half of that to get the measure of the angle. So 150 divided by 2 is going to give us the angle we want for angle B, which is 75. All right. Cool. I figure we'll just do one more and that'll be it for this video. Or we could look at the next two, whatever. Okay, so take a look here. It says in the circle 0, or O, whatever you want to call that, what is the measure of arc A? So this is a good one. There's no numbers there, but it is important to see where it passes through. So notice that this line here is the diameter, right? And if we draw that arc here, well, how many degrees is that? That is 180. And if you notice, that is also made up of these two chords. So the measure of A is going to be half of 180. That is 90. All right, so we could kind of work our way around more problems, right? Just like in this case, just kind of work your way around. But you got it. I guess if we want to do one more, there's angle A, right? What is the measure of A, or angle A? Notice it's made up these two. And so we'll just kind of follow this around. Hopefully you guys get it at this point, right? So that arc is made up of 100 plus 90. We're going to divide that by 2. I'm going to do an 80 bit of work here. So we got 190 divided by 2. And that must be 95. I'm going to go with 95. All right. Awesome, guys. You guys are great. Keep up the hard work. And I'll see you at the next video.